Hello everyone. I'd like to share a circuit I built during the lockdowns of that first COVID year. And what it is a little LED racing game, and the player plays it with a push button located right here. We got a little reset button and a start button that kind of has a little traffic light countdown. And once it goes green, the button is enabled and the game begins. So let's start it off. And you can see the game starts off, it just rotates through these green lights here. And if you hit the button, it rotates through both the red and blue lights. And the whole object of the game is to kind of hit the push button on the blue lights and not on the red. And the higher up the little blue LED ladder you hit it on, the more points you get. And if you manage to hit it on that final white LED, you get like some bonus points on top of that. So we go and just push the button. It moves on to the next stage, and it also shows on which LED did you strike the push button on. And this basically continues for 3 times using basically the same idea. And so you can just push it and you continue on. Now of course you want to avoid the red LEDs, because if you hit it you fall back to the start. But if you manage to kind of successfully complete the game, then your score is displayed up at the top here. And that's kind of how the game works. Originally I wanted this to be a 2-player game, and I wanted to have the mirror of this circuit on the other side, and that way kind of 2 people can race each other and battle it out to see who gets the top score. I thought it would be fun to make a video series building the twin of this circuit. There's a lot of interesting and useful sub-circuits here, and most especially the finite state machine. Now, 3/4 of this circuit, could have been eliminated by a single microcontroller. But I kind of feel that microcontrollers, they hide and sort of the magic of circuits. And when you build different sub-circuits and have them all working together, there's something both is fun and rewarding too. And when you go to take the microcontroller route, it turns out to be more of a programming type of project than an electronic one. And so that's why I chose to go using a finite state machine. And because it's such a critical part of the circuit, I wanted to spend some good time on that to show just how it works. Because when we understand how a finite state machine works and how to design one, well, it kind of like opens the door to create all types of different circuits, and it kind of unleashes your creativity. Because really, a microcontroller is just like a very large finite state machine. So it's kind of cool to know how it actually works, like in depth, right on the bits. So I'll go over a few of the key components here. We of course have the finite state machine, the clock here, a push button, some circuits to display the lights and count through them, a circuit to calculate your time, how long it took you to complete the game, and a math circuit, an add and subtract circuit to figure out your score, and one to display your score. Now the idea for this video series is not to film me sticking in all the wires here. That'd be a bit boring. But really, it's to look over the different sub-circuits and kind of go through the full design process, Think about what we want, how we're going to design it, and kind of pitfalls to watch out for. And, inevitably, we're going to run into some bugs because, as your circuit kind of grows in complexity, unforeseen issues just crop up, and we have to solve them, and I want to include that as part of the video series. And I'll be making extensive use of the oscilloscope to analyze the circuit and to make sure it's like performing just as we expect. But the truth is, if you want to design digital circuits, you really don't need an oscilloscope. I mean, it's nice to have because you get a deep view of what is happening within the circuitry. But if you have a multimeter, that's good enough. I mean, really, all you need is a multimeter and there's an interest in electronics. There's a ton of helpful videos on YouTube And you just don't have to go to school at all to build this. If you're just interested and you got a multimeter and the components, that's more than enough. So this is basically how the LED racing game works, and I hope you guys enjoyed and enjoy the coming videos. All right, everyone. Thanks for watching.